Hey, it's Mrs. Golding. Hope you're having a great day. This is the math packet that you took home with you for remote learning, and we're on page 6 today, problem number 1. So for this problem, this gal named Juliana she was in a walkathon to raise money for cancer research. And so she recorded her total distance that she walked. And at several different points in time. So I saw a word here that was important. This is distance, and here is time, right? But a few of her entries got smudged. Maybe she was sweaty or something happened. And so she can't read all of them. So the times and distances that can be read are listed in what this problem calls as a table down here. I agree, it's sort of a table. It's a little disorganized. It kind of goes slanty here for me. That's a little disorganized. So one of the main things I love about math is organizing, right? Because it keeps everything nice and neat. And I know I've said it before, but in a world where things are in chaos, math can be a nice way to organize. So we're going to organize our information in another way that I'm going to show you. We're going to answer some questions about this word right here, speed, right? So speed, distance here, and time are really important in this question. So she walked at a constant speed. Now, people don't actually do that because we slow down, we tie our shoe, we sit down. So this is not actually something that people do. We can kind of generalize, but we don't, when we walk, we don't walk constant speed, but we can get pretty close. So we're going to it says complete a table. We're going to make an even better table. And we're going to plot her progress on a coordinate plane. Notice you weren't given a coordinate plane, so this is going to be a lot easier for you to do on Desmos or to follow along with me and put it in your notes here. So how fast, so again, speed, how fast was Juliana walking in miles per hour? How long did it take her to walk 1 mile? And next year she's planning to walk for 7 hours, and if she walks at that same speed, how many miles will she walk? Okay, how many miles? So we're going to answer all of those questions. The way I'm going to do it is I'm going to take you to Desmos.com. We've used it on a couple other problems, and I love it. You can use it on your phone if you only have a phone. You can use it on a computer. It's free. So this right here is just a picture of the screen that I'm about to share with you. But what I've done is I have created a table, and when we get to Desmos, I will show you how to create a table again. But I have put in here the values that we were given. And then the blank spots are the pieces of information that we do not know. They were the smudged parts. So notice I have labeled my y-axis and I've labeled my x-axis. And I did that based upon our studies earlier in the year of independent and dependent variables. So we know that the x-axis right here is always going to be our independent variable. That's an example of time in this instance. Time marches on no matter what. It doesn't depend on anything. It just keeps going, right? So it's independent. But the distance that Juliana was able to walk depended on how much time went by because of her constant speed, right? So my distance is my y value, or my independent, dependent variable, y-axis dependent. Okay, so I wanted to show you another little piece of information. Notice I circled the word speed and time and distance in the problem. Maybe you've seen this already in science class. I remember being exposed to this when I was in middle school and high school, and I used it a lot. This is just a nice little way of organizing formulas for speed, which is right here. Speed is distance divided by time. So this little line right here is the vinculum. It's kind of like a vinculum. Speed is equal to distance divided by time. And we can use this to solve all kinds of things. So come back for the next video and I'll show you how to use it.